Hello viewers, welcome to the series on convolutional neural network. In this session we are going to discuss about translation invariance, a very important topic in convolutional neural network and object detection. So without wasting our much time, let's begin. We know that we can train the neural network to recognize an image like this 5. But what happens when the data isn't that clean and simple? If we only train the neural network with pictures of numbers that are perfectly centered, the neural network will get confused if it sees anything else. For example, if we pass in an image like this where the 5 is not centered, the neural network won't be able to make a good prediction. But the 5 could appear anywhere in the image. It could just as easily appear at the bottom like this. We need to improve our neural network so that it can recognize objects in any position. This is called translation invariance. This is the idea that a machine learning model should recognize an object no matter where it is moved within the image. Moving the cat around the image here doesn't change the fact that it's still just a cat. The solution is to add a new type of layer to our neural network called convolutional layer. Unlike a normal dense layer, where every node is connected to every other node, this layer breaks apart the image in a special way so that it can recognize the same object in different positions. Let's see how it works. The first step is to break the image into small overlapping tiles. We do this by passing a small window over the image. Each time it lands somewhere, we grab the new image tile. We repeat this until we cover the entire image. Next, we will pass each image style through the same neural network layer. Each style will be processed the same way and we will save a value each time. In other words, we are turning the image into an array where each entry in the array represents whether or not the neural network thinks a certain pattern appears at the part of the image. Next, we will repeat this exact process again, but this time we will use a different set of weights on the nodes in our neural network layer. This will create another feature map that tells us whether or not certain pattern appears in the image. But because we are using different weights, they will be looking for different patterns than the first time. We can repeat this process several times until we have several layers in our new array. This turns our original array into a three-dimensional array. Element in the array represents where a certain pattern occurs. But because we are checking each style of the original image, it doesn't matter where the image a pattern occurs. We can find it anywhere. This 3D is what we will feed into our next layer of the neural network. It will use this information to decide which patterns are most important in determining the final output. Adding a convolutional layer makes it possible for our neural network to be able to find the pattern no matter where it appears in an image. In this example, we have only one convolutional layer, but normally we will have several convolutional layers that repeat this process multiple times. The rough idea is that we keep squishing down the image with each convolutional layer while still capturing the most important information from it. By the time we reach the output layer, the neural network will have been able to identify whether or not object has appeared. So convolutional neural networks are a secret weapon for image detection. They make it possible to effectively detect objects. It's the standard approach for building image recognition system. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.